Welcome to your lesson on slope. First things first, look at these hills in San Francisco. San Francisco to me is the city of hills. These poor people, look at this hill that they have to walk up. How badly do you think their legs hurt? How steep do you think that hill is? What about this? Who do you think's up here? Write me a note in your notes and tell me who you think those people are standing up there. If you go to John Muir, you know them. How steep do you think this hill is compared to this first hill? Do you think they're the same steepness, or do you think one is less than the other? What about this one? We have cars driving here, but then there are also cars and streets down here. How steep do you think this hill is that we can't even see to get us from this level to this level? So there's a mathematical formula that we used for this, and it's also used on ski slopes, snowboard slopes, any mountain that we're talking about. And we call this slope formula, or y equals mx plus b. Don't ask me why. This is how the mathematicians named it. So our m is our slope. The triangle is actually called delta. So it's delta vertical or over delta horizontal, or the change in vertical. Delta means change over the change in horizontal, and we also know it as rise over run. So we're looking at the rise over the run, with this third line actually being our line that we've graphed. So we say it makes a slope triangle to be able to measure the rise over run. And our y, our b, is our y-intercept, or where the line touches the y-axis. It's our starting point. So when we're graphing slope, we actually go backwards. We start at b, and then we graph m, and that gives us our line. So let's do some sample problems. Go ahead and write sample problems in your notes, and write down this first problem. We start with our b, so let's actually write our formula. We have y equals mx plus b. Our m is a fraction because it's rise over run, or change in vertical over change in horizontal. So we start with our b. Our b is -4. So on our graph, we need to go down 1, 2, 3, 4. And this is where we're starting. That's our starting point. Notice that it hits the y-axis. Okay, now we need to rise 3, run 1. Every whole number is over an invisible 1. So we're going to rise up 3 and run over 1. So our second point goes right there. So now we're going to graph this line. Remember, our line goes past these 2 points, and it has arrows on the end to show that because it's a line, it's going on forever. And when we graph a line, we use a ruler, so make sure you have a ruler. So again, I know I graphed this correctly because it starts at -4, and my slope triangle goes up 1, 2, 3 over 1. This is a positive line. If I were walking upstairs, I'd be walking up, 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 up. It's going upstairs. All right, let's try the next problem. For this one, it wants me to start at +2. So I'm going to walk up 2, and that's where my first point's going to go. My slope is -4 over 3. This negative I can assign to the 4 or to the 3, but only one. I can only assign it to one of them. It makes it a negative fraction because one is negative and the other is positive. So I'm going to go down 4, 1, 2, 3, 4, and write 3, 1, 2, 3. That's where my second point goes. Now I take my ruler, and I want to make sure I'm matching up on the corners. So where the lines make a corner on my graph paper, I go past my points, draw arrows, and here's my slope triangle. All right? But what if I don't have points? Well, first things first, we need to make our graph. I mean, what if I don't have my y equals mx plus b? What if I don't have my slope formula? So we're going to actually make it. We're going to work backwards. All right, here's my graph. This is my x-axis. This is my y-axis. And I need to plot these points. So my first, remember this is x, this is y, this is x, this is y. So first things first, walk 1, climb 5. There's my first point. For my second point, I walk -3, climb down 2 because it's negative. There's my second point. So now I need to connect these 2 points. When I connect them, I need to be very specific. So I'm looking for the corner on the graph paper, and I'm going to try to draw my line through that corner. It's going to be hopefully closer than an approximation. We want it to be as exact as possible. So now we need to write our slope formula. So what is my slope formula? Let's remember. Slope formula is, y equals mx plus b. So this is what I'm setting up. So my y is going to be the same, equals x plus. We just need to fill in the m and the b. So coming up here, my b, where I always start, where does it hit the y-axis? It touches right here. That is 1, 2, 3. So it touches at +3. My slope, I need to make a triangle. So I'm going to connect my 2 points, but I'm following the lines on the graph paper. So here's my 2 points connected. Here's my slope triangle. I had to go 1, 2, 3, 4, 5, and 1, 2, 3. My slope triangle is 5/3. This is a positive line, so my slope is +5/3. So, quick review. We have a positive line. We started at -4, climbed up 3/1. Here we have a negative line. It's like we have to walk downhill. So we started at +2. We went down 4, right 3. And here we graphed our points. We have a positive line. It's going uphill. And our line formula is 5/3 x plus 3.